It should go live any minute. Oh, maybe refresh. Yeah. Okay. So, hello everyone again. Now I'm back to having good actual internet, so I can go and continue streaming stuff, which is really nice. And with some really good isolation, self-isolation vibes, we're gonna go and try to learn a new programming language, that is Golang. And yeah, so I was gonna have a face cam, but then I noticed that I forgot the right cable from where I spent 3 months in, and now I don't have a cable for the face cam, so we'll have to deal without that thing. Also, kernel series, it's coming back, so hopefully, I think so. It should be coming back. I was gonna like make a really good series out of it, but I just got carried away with other stuff. But this time around, we're gonna go and learn Golang, which is, I don't know, seriously, I don't know. It's a language made by Google, and I was told it's very good for backend. It's like kind of a Java replacement, and also it's very well paying. So those are my motivations to just learn a new hot skill, have a new popular tool under the tool belt. And how are we gonna do it? So here's the thing, I'm doing this completely unprepared. So this is just gonna be raw learning of Golang. And why I'm doing it unprepared, live streaming it, well, because like I know quite a few languages, to name a few: C, C++, Rust, Java, and stuff. So after a while, you kind of notice different patterns of the programming languages being pretty much the same, like rather similar. You notice these patterns, and it becomes rather easy to pick up on them and pick a new language up and learn it. But it's something that you figure out only after like learning 4 languages or so. So like for some people who are just starting out, it's not like an easy thing to pick up on because they like know 1 or 2 languages. So this is where this goes in. I'll try to explain what I pick up on and what what key things I notice about the language that is Go. And well, first of all, I have no idea what I'm doing. Let's search Golang. All right. We first start by going into the website, and that is open source programming language, simple, reliable, efficient. That's very much like Rust, I gotta say. And it's package. So package, I guess, it's like similar to modules in Rust and headers in C, C++. I mean, yeah, something like that, I suppose. Import, it's like Python's import. Func main. So the function definition seems to be func and then the name. I don't know what about the return types. And hello. What does it do? Hello. Does that mean world? Does that mean world? I think so. It should be. Right, game of life. Well, this is a really small window, maybe open in playground. So like they do have playground, which is like Rust has a playground. And So package, same thing. Import. Are these? Okay, so these are these things. Okay, that's weird. Alright, so it's same as Rust. It has func. Well, Rust has fn. Function name. It seems to be using camel case by default, and then the return type. So similar to Rust. Alright. But Rust uses snake case. Okay, now this is confusing. Huh. What? Wait. What? Alright. Alright. I have no idea. Okay, so let's read a comment. Comments are always the same mostly, except Python. There's Python and Lua, which have like, which decided to use hashtags and double dashes for some reason. So alive reports whether the specified cell is alive. If the X or Y coordinates are outside of the field boundaries, they're wrapped theoretically. Well, this isn't, well, it doesn't explain the syntax. So we will have to go into the docs. Oh, hi, Delusion. Nice, Rust. I love Rust. But it's always time to pick something else up. I've been doing Rust for like months and months now, and I'm loving it. So good luck on that. It's a really cool language. All right. Documents. Do you mean documentation? All right. Getting started. All right. That's nice. Getting started. Is this for Linux? So I wonder, on Rust, use rustup even on Linux because it's just better. How about Linux? Because my main machine for development is Linux. It's just that I'm running on a VM. So, yeah. Which is interesting. Perhaps install Go on Fedora? I don't know. Alright, let's see. What do they recommend? Okay, so it means recommend using the package manager, I think. I suppose. Because like these guys, they don't have a script set up. So it's probably like if you just want to run it anywhere, it might work, it might not. Wait. Maybe installation is So that's the thing. That's the thing with like these new languages and stuff, is that it doesn't say anything interesting. So yeah, let's just try package manager. If it's wrong, then we will go back to tarball thing. Wait, is it Go or Golang? /user bin. That's probably not the best idea because it clutters system files. Although, okay, let's see. let's see if Fedora has like the Go version set right. Okay, it doesn't. Go version 1.13, yeah. And this is Go 1.14. Let's just do it as per docs. Yeah, 400 megs. We love fast internet. So, alrighty. Installation instructions. It will be just user/local. Yeah, that seems right. Yeah. Yeah, that's fine. Okay, where should I download this? All right, well. Okay, that doesn't sound right. Here we go. And oh, it creates a user local Go. All right, cool. Okay. Permission denied. Yeah. Here we go. Yeah. And then add path. Yes. Do I have it somewhere in the bottom? Because where's my where's my Rust path? I forgot. Is it bash profile? Yeah. Here we go. Go. Is it go bin? Yeah, bin. Here we go. Huh, here we go. Right, that closed it. Well. Okay, that didn't work. So it, oh. Wait, I forgot my bash configurations. Now I'm running Windows on Fedora. It's a PCI pass-through thing. It's the other way around. My host is Linux. It's a weird setup, but using DMA stuff is just how I do it. Right, user share modules bin. Wait, does it? Did it just export cargo twice? Alright, let's just add it to ZSHRC. This feels so bad. Okay. Because because I feel like a total noob right now, even though I've been running Linux for ages. So like the thing is, I really love the Cascadia code font. Like Windows Terminal is really nice. And my PC only has 1 GPU and I do game a lot. So I kind of need Windows for that kind of stuff. But like most of my development is done on the Linux host itself. So I just SSH back into it. I set up like the actual default profile for the Windows terminal to go SSH into it. And you know, I set up X server. I set up X server to run on Windows. I mean, it's actually like running on the Linux side, but still, I could there's Virt Manager, and here Windows 10. I could click on it, it opens it up, and then it messes my mouse up because, well, I'm trying to control mouse through there, which moves it on the host. And yeah, so basically this is my setup, and yeah, it's weird. but that's how I do it. Which is basically on the tool I'm working on. It's called ManFlow, and it basically needs me to have the setup. Well, I kind of finishing it up. It's a DMA tool, and well, it's gonna be really cool when it comes out, once it comes out. So yeah, Go version. Here we go. Haha. Here, so getting started. So yeah, we have this. All of this, we have hello.go. It should probably, so just go build. We set it up. It took 18 minutes. All right, I'm back. So tour of Go. That's cool. Oh, I didn't need to install it. List of modules. You can also view the table of contents by clicking the menu. Yes. Using the Torah. Go local, go offline, the Go playground. All right. All right. Oops. So, interactive, shift enter. Program exited. That's cool. Yes. Oh, Go FMT. That's like Rust FMT. That's cool. So like if I just add this, yes, we love it. If you do some crazy things like this, I think I misclicked. So if you do some crazy stuff like this, this should technically format it out. Oh, I just broke it. That's cool. Oh, yeah, let's do it. Here we go. Oh, but once it is like that. Oh, it doesn't format it. Huh. Like Rust completely changes the lines if you like have it on like this. But well, it's still good enough. All right. So it has formatting, it has the web compiler, probably WASM. Or maybe just interpreting, I don't know. Syntax. Okay, so like, I hate these buttons because right now I think that syntaxing is off. But when I press it, it turns on the syntax and it says syntax on. I mean, maybe it's just like the Linux theme, but like the coloring is not very good. Imports on, imports off. Okay. Enough nitpicking. It's good enough as it is. C++, well, they do have compilers, but it's not as straightforward as Go or Rust. So, here we go. Next. Available languages. I'm disappointed there's no Lithuanian translation. Well, at least there isn't. Well, I'm disappointed. Safe to say. I can't use it. I just... Well, okay, I can. Maybe I can. Okay, that's cool. Let's try to get it on the thing. CD projects. Maybe let's just do... Wait, did I do the installation completely? Did I complete the installation? Because I only installed the thing, but did I set up the environment? Did I set up the environment? I mean, I set up the Go paths. Yeah, alright, cool. That's great. Good. Here we go. Oh my god, and I gag in all the time when I hear it. Here we go. And why is it... It didn't have any progress bar. Wait, what? What? Wait, where does it... Where does it go? Where's my workspace? Where's my workspace? Okay, so the actual workspace. Wait, does it? It only shows the Go binary paths, but yeah, it's Go. Yeah. All right, thank you. And we have. All right, so it's structured like this. Okay, that's a lot of stuff. It has licenses and stuff. Net. Oh, I only need to go to the door. Go path. It's unset for me. I probably didn't set it up properly. That's why. It defaulted to home/go. Which is fine, because after a while you realize that it's probably best to leave things at their defaults, because other things break if they're not at their defaults. It's like the same thing as you could technically change your Windows installation to be on the D drive, but that's not what you want to do. Yeah, that's what I love. Like, Go is like, so Go is very similar to Rust, as in, like, one way. Rust has cargo, which is also one way, which, like, is really cool, because on C++, you have all these different build systems, and, you know, it gives flexibility, but the only reason there are many build systems because all of them are horrible. All of them are horrible. They have header files and stuff, and that stuff is like from C days, and you can't fix it. So you, like, we had Make for the longest time, and, like, it's slow. They created Ninja, which is faster, but still most people use Make. And I'm just glad that a new language steps in and creates everything properly, instead of, like, all right, we have a language, here's a compiler, but it compiles one file. That's not good. It's good when the language has, like, the whole pipeline set up, which I love, which I can see I will be appreciating a lot. Oh, okay. So now, just like the code structure, I'll need to look into code structure because there's a lot of stuff in here. So there's gotour, gotour, main.go. All right. It says it moved. Well, we probably decided to go into exactly the wrong directory. Tour.go. All right. So, lots of imports. Well, I'll probably go check the website. So, offline optional, I did set that up. Playground compiles, links, and runs. In the playground, time begins at that time. Significances of that time. It's probably some. Is that the 1 billion seconds? I'm not sure. It could be the 1 billion seconds since the start of UTC. Maybe. I don't know. Because 2035 is the end. Or 2 billion seconds. I don't know. The 35 problem is when it overflows. Probably overflows 4 billion instead of 2 billion, which is 2 to the power of 31. Yeah, it should be something about that, around round number. There are also limits on execution time on CPU memories. Yes, that's actually fairly fair, because I don't think they want me to write a Bitcoin miner. Alright. And congratulations, first module. Or go directly to the next lesson. Here we go. Packages. Every Go programming is made up of packages. So they start in main, which has the main function, and it also has to be a package called main, which is fair. In C, it just needs to have a main function, but it can be whatever you want, and it makes it hell to find where the main function is. Well, grepping is easy, but this is good because you always know you can find where the main is. The program is using packages with import paths, FMT. So it's like namespaces as well. So like this is the package. This is the package, and this is like so this is a module, I suppose. The rand module from math. Which is interesting that random is part of mathematics. But yeah. The environment in which these programs are executed is deterministic. So each time you run the example program, rand int number will return the same number. So you need to seed it to have it different. Seed the number generator, use rand seed. Time is constant in the playground, so you will need to use something else as a seed, or rely on frequency fluctuations. That's also a really good RNG. But yeah. It's interesting how you need to use something else, but we won't provide a solution. I mean, it's fair to have it, all the examples break deterministically. That's good. That means bugs can be reproduced deterministically. Imports. So wait, yeah. The code groups the imports into a parameterized factored import statement. Oh. So it's like, so it's just like if you want to have a list or something, you can do that, or you can just do like everywhere in like Java and stuff you do. So like the only difference is that it uses these parentheses instead of like curly brackets that most languages would use. But you know what, it's fine. Also, it doesn't use the comma separator. It says parenthesized factored import statement, even though you would normally parenthesize using comma. Does it compile if I put a comma? No, it doesn't. So that's something important. Why does it? All right. You now have a lot of problems. Okay. Also, the printf statement uses like C-like print, whatever G means. It means OG number, probably. Exported names. In Go, a name is exported if it begins with a capital letter. Huh. Oh. Okay. Well, that's something weird, not gonna lie. I guess, like, you know, what is public, what is private in terms of the code. But then like, all right. So does it not have a public identifier keyword? Pub. No, it definitely doesn't. So if it was main, but then it doesn't get called. So yeah. So let me just write interesting things. Public names are capitalized. Start with lowercase. That is surprising. Okay. Run the code. Notice the error message. Undefined pi. rename pi to pi. Also, like, after it fails compilation, it doesn't exit, it requires you to kill it. Is that intentional? I don't know. But yeah, functions. All right. Functions can take 0 or more arguments. In this example, add takes 2 parameters of type int. Notice the type comes after the variable name. Goes declaration syntax. So it's like Rust, but it doesn't have this thing, the column, and it doesn't have the arrows either. For it just like goes immediately, skips the symbol and goes to the type, which is shorter indeed. I guess that's kind of readable. If you have syntax highlighting, that sure is. And run 55. I think that's as expected. Let's see, it goes declaration syntax. C took unusual and clever approach to declaration syntax. Does declares. Set it P because P has type int, etc., etc. What about functions? Originally, C's functions declarations wrote types of the arguments outside the parents, like this. What? That's pre-C89, I suppose. And thank God they changed that. Yes, but the basic structure is the same. But it can get... Yeah, function pointers in C are confusing, yes. What if one of FP's arguments itself is a function? Oh God, wish me luck. Wish me luck. Although, like, you wouldn't really define the names. All right. So, yes, it is confusing, truly. The Go syntax use distinct type syntax and declarations. The name usually comes first, often followed by a colon, like Rust. Yes, yes, yes. Clear if verbose are clear if verbose, you just read them left to right. Yes. So it just makes it a little bit faster. And also, yeah, pointer. I mean, this is like... But yeah, I get it. It does like this. So it makes it shorter, which I like, indeed. But I don't like array size. I mean, I will grow to like it. I swear. I say I don't like it because it's unusual, but I mean, it's just a difference. Array sizes are defined before the type. And here we go. So, but what was that function I noticed? Yes, it's all same, it's all same. It's all same stuff. Yes, it's all same stuff. Pointers are exception that proves the rule. Notice that in arrays and slices, for instance, Ghost type syntax puts brackets on the left of the type, but the expression syntax puts them on the right of the expression. For familiarity, Ghost pointers use the thing notation from C. We couldn't say. And perhaps we should have known. All right. One can write int high. As a conversion, one must parenthesize. Yeah, that's true. For conversion, you would want that. So like it's rather similar to C, but also highly different. The pointers stay the same. The arrays are, though, different. And you know, okay, it's a bit clearer now. Although I kind of still don't get what was in that game of life example, where it just had so many types scattered. Well, I guess we'll figure that out soon enough. Functions continued. Yes. Oh, okay. Yes. That's cool. Why does it say audio bitrate is 0? What? Can you hear me? Yes. So the stream suggestion says it just broke. The audio stream's current bitrate is 0. Is lower than the recommended bitrate. No. It's not the way it is. It's working just fine. I have 0 dropped frames. Okay, YouTube. Thank you very much. Right, so I like this. If you just have like integers, you can just pass it like this. I like it. So Go is like really short, I guess. So they could have made it FN instead of func. Although, because FN is just 2 characters and func is like very scattered on the keyboard, unless I guess you go on Dvorak or something. Why would you? I mean, you would if you wanted. It's really cool, I heard, but it's just not something I would take up on. Multiple results. Okay, so that's a tuple, basically. Again, my bitrate is 0. It's not. Does it become too quiet and it just messages me that? Or are you just spazzing out? I'll just ignore you. So it's a tuple, although it doesn't do it like this. It does it like Python type, where it like returns it. And here it's not tupleized. What if I just do this? So can I do a or is it? I just wonder. It probably is wrong. Okay, so you can't hold it in one value. So that's not like Rust. So it must be A and B. Okay, so it's not, it doesn't actually have tuples. Although it's defined like a tuple. That's fine. Use underscore. I mean, so like, so yeah, what I was thinking of is not like dropping the value, but like having it in one value. So like in Rust, if you have like tuple of type string, you could access it using tube.0 and tube.1. So it's like a distinct type, and in Rust, if you were to just do it A and B, you would have it parenthesized, and you then would be able to access A and B individually. But yeah, that's just like I was trying out if it's similar to Rust, which it is not. Although the underscore, that's good that it has it, because I can just drop the variables right in there. But yeah, it doesn't allow to hold the both values in a single variable, unless there's some specific syntax I haven't reached. But yeah, thanks for the underscore, it's good to have it. It's good. It's a good part of any language that has it. I know only Rust that has it. Named return values. Or what? Go's return values may be named. If so, they're treated as... Can I increase font size? I hope so. Yes, here we go. Yeah, I suppose, yeah, it has to be pretty small. Thank you. Thank you for letting me know. All right. Go's return values may be named. They're treated as variables defined at the top of the function. These names should be used to document the meaning of the return values. A return statement without arguments returns the named return values. This is known as a naked function. Naked return statements should be used only in short functions, as with the example shown here. They can harm readability in longer functions. They sure can harm readability in longer functions. Oh, all right, okay. Yes, so it can just like return these specific types. That's cool. That's just cool, you know? That's pretty cool. For a moment I thought that this would set it to XY here as like a variable, which would be a disaster. But this is fine. Yeah, that's a nice syntactic sugar. I won't add that in because it's like something you would so like this part of the syntax is something I would probably skip for a lot at the start of using Go, but then as I use it I would discover it again and just like learn it again and just start using it. But it's like not an essential part of a language, and it's good to know it, but it's not like a necessary thing to know, and I could just skip it if I wanted to learn the language as fast as possible, because it's like a nice syntactic sugar, but it's not like a necessary thing for you to know. So here's that, which is, you know, interesting. Variables. The var statement. And type is last. So these are globals. Yeah, they default to false. Package or function level. I can see both in this example, and if it was like capitalized, it would be public. All right, so yeah. So wait, so it has it like this, but how about here? So also I just noticed right now that there aren't any semicolons in Go. It took me so long to notice that. God. So wait, in. So this won't compile. Unexpected end of end statement. 32. Oh wait. Undefined O. What is the difference between here and, so if I have it Z, does it undefine Z? But I guess if I return it, it does compile just fine. So that is a little bit weird. So I can declare it. Can I? Undefined O. Okay, so I can assign it, but I can't like just use it like. So if I just have I equals 0, undefined. Huh. Okay. I mean, it's good that it's explicit, but it's just confusing. When is it explicit? When is it implicit? When you have to define it as a var, and when is it not? Okay. Okay. Variables with initializers. Yeah, we got it. Oh. Oh no. Oh no. Ooh. Okay, this I don't like. Because if you get to like over 5 variables, it becomes impossible to manage it. Although maybe it's faster to change things. If it's like just a different A, B, C, D ints, you can very well change it. Which I would agree on this. But mixing types? Oh no. I love how you just added no right here, because it's not. I could see getting confused. Short variable declarations. Oh, okay. Here we go. That's what I missed. Short declarations. Okay, so. Hello, Foxy Skater Fox. Yeah. Good luck on your journey. But yeah. See ya around. So we have. Can I increase the font size? Oh, yes. That's cool. So variables can be defined either using var name or okay, cool. Yeah. Basic types. So we have bool, string, integers. Those are like similar to C++, although they don't have _t. And byte. What is rune? Under Unicode code point. So just a Unicode character, I suppose. float 32, float 64, complex 64, complex 150. Wait, complex. Wait, what? Complex would be these. All right. Here's a little fun thing. Did you know that C99 has complex numbers built in out of all features? Out of all features, it has nothing, but it does have C99. Also, is this a mandatory thing? Oh, well, at least it's formatted automatically. Okay. 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 Well, yeah. So we do have complex numbers in Go. Go has complex numbers. Here we go. And that's a primitive type, basic type. Maybe factored into blocks. All right. Oh, well, you can just do var. This is cool. Just having a complex number, like, yeah. Zero values. Zero value, 0, 0, yeah. That's cool. Type conversions. So you use t and value. This is like Python, where the C style cast is C style cast is TV. Go style cast is like Python's TV. All right, that's good to know. Oops. Shake things up. Okay, that didn't work. And unlike C, Go assignment between items of different type requires an explicit conversion. Thank God for that. Although, like, in C, that's probably the reason why they did it, because it was just like horrible with all the pointers. But in Go, explicit conversion, I like that. Type inference. Huh. Type inference, and that's cool. Can I do J? No. Complex, it's only the I. That's fair enough. All right. Okay. Constants. Constants can be declared like this. Oh, constants cannot be declared like this. Constants must be said const. And yeah. All right. And also, you will never know if it's a constant or not, which, to be fair, is not something you would normally care about. You wouldn't really care if it's a constant or not. So just having them start with an uppercase, that's good enough. Yeah. Numeric constants. What is Rust mainly used for? It's, well, Rust is basically like C/C++ replacement. I mean, many people will get mad at this, but, well, probably none, because no one watches this. But basically, it's like used when you want to write fast, like super fast code that compiles to like machine code and like runs as fast as C, but also safe. it won't crash because of the borrow checker and stuff. So that's why that's where Rust is used. We are currently working on like a library that parses. I could actually show it to you. I think if this will compile, hopefully. Cargo run. Yeah. Oh wait, cargo run. Let's just do core dump. Is basically a library that allows us to wait. Let's remove that verbose thing. It allows to look into Windows processes through externally, and it basically like module ls lists all the DLLs loaded in a process and stuff like that. And it's written in Rust because Rust is like, it's a rather high level language, but it allows you to go low level, if you get what I mean. It allows you to like deal with basic byte arrays and stuff, directly interoperate with C libraries which like don't have a concept of a class or something. It allows to go like close to the hardware while still staying safe, because it like has a compile time guarantees of things being safe. So that's why we chose Rust, because this project deals with like low level stuff of like Windows kernel structures and like memory reads. So we could have gone with C, and I had a previous project which used C, but it just like takes so much code to write stuff in C, and it also won't be safe. So that's why we picked Rust. Basically, that's the type of stuff you want to have Rust in, where it needs to be fast, it needs to be efficient, and it needs to be safe. Basically, wherever you would put C or C++ in, Rust would work just fine. And also networking. Like you could actually have a backend written in Rust, but more like not a web backend, but like some backend of like a system that like passes binary data through. That's where Rust would be useful. And like various tools, command line tools, would be useful to have them in Rust, because Go, from what I heard, it like has two main things, like garbage collector and like a runtime, which are rather big. So it like is quite fast, but it's still like kind of like not super fast as Rust could be, although like Go compiler is much faster. And also Rust is very, very good for WebAssembly, because first of all, it's already safe, and WebAssembly like has a official support from Rust. So like I saw a talk about this guy told that most of the stuff used in web client side in the future will be written in Rust. That, at least that's what he claims. Because, well, because Rust has like a very minimal runtime. It has no runtime basically, and you can just compile it to WebAssembly, put it in, and run, and it has official support, and it just works. And yeah, so Rust can be used for backend API, and I could basically use Rust anywhere. But like Go is like specifically targeted towards backends, for like web backends. I'm pretty sure from what I heard. And Rust is like more towards systems programming, but there are lots and lots of wonderful crates, which are packages, that support making backends. And you can very well write a backend in Rust. And there is like no problem with that. And if Discord is switching from Go to Rust because of speed, then well, it's probably something you might want to go with if you want to have things as efficient as possible. So, I mean, it's choice of what you wanna sacrifice. With Rust, like, I don't see many sacrifices with Rust other than it is like slower to get started with because the compiler will always complain about things when you do them improperly, but once you get them done, usually it just works. With Go, I could see, like, I don't know, I don't have any experience with Go, I just telling from what I heard from other people is that it first of all has garbage collection, so like memory is managed kind of automatically for you. I'm not sure, I don't know. But like, it's something that you don't need to care about. In Rust, you need to care about in the code of the order of things go in, because it just won't compile. But once you get it to compile, it works flawlessly, usually, most of the times. But yeah, so like, you could go with Rust for backend API. I very well would. Can we write a Windows driver in Rust? I think so. I very well think so. Rust Windows kernel driver. With Linux, it's a bit different. Like, all right, so like there are guides. It might not be as supported as C/C++, but it does work. On Linux, it also does kind of work. They're planning on allowing Rust in Linux kernel, which is really cool, but the support is not like fully fleshed out. But eventually that will be the case. But yeah, Windows driver in Rust, that's something you can do. I think I haven't tried it, but people say it has been done. But yeah, back to Golang. Here we go. Oh my god, I always say it and I feel so bad because it's such a horrible pun. But yeah, here we go. Numeric constants. High precision values. What is high precision values? What does that mean? Oh, does it like, okay, so like it does like the operations. It like it's kind of like a define, I suppose. So it does the operation, but it adds these operations together, like the bit shifts, and it like takes the minimum or something, and it like becomes like 1 shifted by 1. That's interesting. That is interesting indeed. Okay, so what if intermediate equals big plus -5. Can we do it? Okay. I just wonder what it expands to. what do you expand to? Oh, or maybe it messes up a little bit. 1.267, 1.267, 1.267. Yeah, I think it does like mess up quite a bit. I'm not sure. But it's a cool concept. As in like it just like compiles this down to this and that applies it here, so it like doesn't, you have it like lossless. You have it lossless. That's cool. Yeah, congratulations. Yes. For loop. Okay, basically C style for loop. That's all. That's all there is to it. There's C like for loop, C style for loop with no parentheses and go declarations. Yeah. Here we go. The punkag. That's all. For continued. Init and post statements are optional. Oh, so that becomes a while loop. While why is this not optional? It it is also optional if sum 1000 can we break. Is there a break statement? Yes, there is. Yeah. Okay, so that's also a thing. It's literally a C for loop. For is goes while. Oh, okay. It could also be used as a while. Does it have ranges? Yeah, it's a Rust's loop when it's having everything omitted. It is like Rust's loop, which is they just decided, you know what, we're not adding extra keywords, and you know what, it's good for refactoring purposes, I suppose. Cool. I mean, I kind of like when Rust syntax, when it just, you define a range 0 to 10 and it just works. I guess Go doesn't support that, but that's fine. If statement, that's cool. If with a shorthand statement. Until the end of if. So I guess you can like put it an else. So if like, if thing, okay, that's cool. That's a really good syntax. So if you need to have it in scope and also check it here, you can define it here. and it will only compute if it gets to this particular check. So if there are checks beforehand, it doesn't do anything, like it doesn't compute this. So that is a good decision. that is a good design decision. If and else, yeah, cool. Wait, does it have anything interesting? Loops and functions. Given wait, as a way to play with functions and loops, let's implement a square root function. Given a number x, we want to find the number z for which z squared is most nearly x. Computers typically compute the square root using a loop, starting with some guess. You can adjust z based on how close z squared is to x, producing a better guess. So z, we can actually write actual code for, can we do, no we can't. And yeah, ooh, ooh, which is it? Wait, I need to do it like this. Oh, I need to actually return. Wait, no new variables on the left side. Ah, okay. Here we go. We did it. We did it. Repeating this adjustment, implement, no matter the input 10 times. Da, da, da. Or just do it like this. Stop once. Let's try it. For BZ Z BZ BZ minus Z is less. Or BZ Z minus BZ. BZ equals Z. Wait, it has to be like this. Can we do it? 1. Oof. Can we do it like this? Alright, so float 64. Here we go. We did it, I think. How many iterations? 0. Is there? Yeah, there is. fmt.print ln. How many iterations do we have? 3. That's actually okay. So That's actually cool. I didn't know how the floating point things worked. Maybe the CPU does it the same way. Can we increase the precision? 4. Let's just have it like this. 4. 5. Jesus. It needs only 5 iterations. I mean 6. This is some ugly code. Okay. It became actually 0, so. Timeout. 0. Okay, yeah. Well, 5 iterations. That's something I learned today. You can actually calculate the floating point number. I'm not gonna go into the rest of the, like, try it out. Switch. C-style switch. C-style switch. It can also be value, like not a constant. And also you don't need to break. C-style switch. No need to break. There is no fall through, which I say thank God for that. And because you wouldn't even want to use a switch case statement ever. And can be any type, and cases don't need to be constants, which is cool. Can you like switch OS? Go runs on Linux. Yes. Switch evaluation order. From top to bottom. Yes. Time now. Time. fmt.print. Let's figure out. Is it 2 billion? Time dot now. Is it? Let's see. Go docs time. Okay. Okay, the docs. Okay, these are better. Overview. Okay, Rust docs are so much nicer. Seconds. Dot seconds. Time has no method seconds. All right. All right. Yeah, I suppose searching Golang might be better. Is it time? How do I convert time to time? Time second. Time dot second. Here we go. Oh, I mean seconds since UTC. Unix. Maybe Unix. Is it? Is it? No, I have no idea. What's its significance? Seriously. Wait. What's its significance? Let's see. Okay, so ticking doesn't change. Wait. Okay, so wait, it's okay. I don't know. Well, probably I was wrong. I was probably wrong, most likely wrong. Well, okay. Let's go. Let's go to the next. Switch with no condition is same as switch true. You can use it to write long if then else chains. I have just a single question. Why? Why would you? Why? Why would you? Why would you want to do this? It becomes longer than if else by one line, and it's also, it's just, I don't know, maybe there are some useful applications for this, but I don't get this. Maybe once I start using it, it will become cool. But right now, I don't feel like this. Defer. Defer statement defers the execution of a function until the surrounding function returns. The deferred call's arguments are evaluated immediately, but the function call is not executed until the surrounding function returns. So is this like something about coroutines and stuff? Like, is it like futures in Rust? I'm not sure. Perhaps there has to be so much more to it because they have it and it's in the tour of Go. But right now it's like, it seems pointless. Stacking defers. A deferred function calls are pushed onto a stack when the function returns. Deferred calls are executed last in, first out. Huh. So is it like, what? That is weird. Why would you? Why does it have two? Why does it have 2 pages on deferred? Defer, panic, recover. Wait, Go has go to? If you have an error, it will run the defer. So I suppose you can like cancel it. You can. So I guess it's useful to like in C code. In the Linux kernel, you like go to the cleanup phase if you fail, and it like undoes the stuff. So I suppose like this defer, you queue the undoing steps if something fails in the middle, but then you must have an ability to cancel the deferred statements. Otherwise, it just doesn't make any sense. And I suppose it has a way to clear the list. Alright, cool, fabulous. Contents. So opens two files, ds, return, copy, close. This works, but there's a bug. If call to os.create fails, the function will return without closing the source file. Does Go not have constructors and destructors? Yeah. This is a good way for our error handling. Like, yeah. Yes. Oh, wait. It still is. So this just like defer a destructor. This just defers a destructor. So like it doesn't. So like seems like Go doesn't have a concept of destructors. So you just defer it, which is cool for being explicit. All right. Yeah. Yeah, and it functions like a stack, like variables on the stack. Yeah. That makes perfect sense. Okay. Next example. Panic is a built-in function that stops the control flow and begins panicking. Any different functions are executed normally, and when the car behaves like a call to panic, the process continues up the stack until all functions in the current go routine have returned, at which point the program crashes. Yeah. Recover is only useful inside deferred functions. During normal execution, a call to recover will return null, which is, I suppose, a null pointer, null reference, and have no other effect. If the current go routine is panicking, a call to recover will capture the value given to panic and resume normal execution. Here's an example program that demonstrates mechanisms of panic and defer. So we call f, which defers this function. Recover, yes. Calling g. Yeah, panicking. We have a panic, which then Golang G, defer in G. Yeah, it defers a call to GI plus 1, it then panics and it returns from here. Okay, the control flow becomes rather convoluted, but I guess I can see the use in it. Calling G, panicking, defer in G, 3, 2, 1. Okay. So wait, we first call G, yes, and it prints. All right, it calls in defer in G, panicking, defer, unwinding, recovered in F4. Okay, it prints the value. Yeah. Okay. All right. Yeah. Cool. A tour of Go. Congratulations. Next section. Pointers, my favorites. Is there a reference in Go? So we have pointers, yes. Zero value is nil, like Python. So yeah, we already know the basic syntax. We already know it generates a pointer, denotes the underlying value, yes. Dereferencing. There's no pointer arithmetic. Which I guess is fine, because Go is not a C-like language. No pointer arithmetic. Structs. So wait, type vertex. Okay, why is that? Using a dot. Same as all languages. This is same as all languages, basically. Pointers to struct. Okay, the dereferencing is implicit. Dereferencing struct members is automatic. And a dot, not a arrow. All right. So, I mean, they could have done that, like C, but decided not to. Which I guess it's good from refactoring purpose. If you change it from pointer to value, it will work. Struct literals. Okay, so you can just list all the values in and it will assign them, or you can specify which values you assign, or you can leave it all automatic. And also it creates a pointer to this. So wait, what if we run it? So it creates a pointer to this. So I guess this is like garbage collection happening. We have a pointer to that. We have a pointer to this particular object, so it doesn't free it until we drop the pointer itself. And the garbage collector knows we can release this memory and it's free to use by anything. So that's like one of the things in Rust. If you were to drop this, in Rust you wouldn't be able to do this, because that value would go out of scope immediately. It would be automatically freed, and this reference, pointer, it wouldn't make any sense because it would point to the data that's like already freed. But in Go, it takes this and it knows that you have this pointer, so it keeps this around until you drop this, until this disappears, becomes inaccessible. So that's like garbage collection. It makes things easier, although less efficient. Arrays, yes. Go provides a convenient way of working with arrays. Slices. Slices, yes. Slices. This is like Python. Slicing is like Python. Array slicing is like Python. So that's something you kind of know after you program in Python, that you can like sub-slice array, which means like take a part of the array and use it elsewhere. Although, is it like by value? What if I modify primes? Does it modify this? Huh? Let's see. 3 equals 33. Can we do it? Yes. Alright, so it subslices it, and it's not a copy of the array, it's rather a reference to it. So like if you modify primes while you have this, the values inside this change. This is something Rust doesn't allow. It just doesn't allow you to hold reference to this, or modify this while you hold a reference to this. That's something like, it guarantees safety, but it's more limiting. But this just allows you to do anything you want. Yeah, basically. Yeah. Slice literals. This is an array literal. Then this creates the same array as above, then builds a slice that references it. So you like don't need to describe the size of it, but then you access it by reference, not directly. That's fair. Slice defaults. So yeah, so this is like a range, and this, so you start from the start and go to the 2, start from 1 and go to 4. 4 is like not something, so it goes 0, 1, 2, 3, 1, 2, 3, not 1, 2, 3, 4. And yeah, that's cool. Slice length and capacity. Slice has both a length and capacity. So why does it have a capacity? So like the length is like the length of the slice, and capacity is the number of elements in the underlying array, counting from the first element in the slice. What is the point of this? What is the point of it? Okay. All right. So you allocate an array of size 100. You start with slice size 0. You want to add an element, so you reslice it to be size 1, insert the element. And then you can repeat this in resize 1 to size 2, add an element, and then you can do it until you reach 100. Once you reach 100, well, then you can't do it. Extend its length. Extend its length. But wait. So what does this mean? If I do a 3 and then do a 6, run it. 2 3 5 7 2 3 5 2 3 5 7. Huh. But what if I do a this? So we have 4. Huh. This guy's confusing. I guess, like, because it doesn't extend it. But unless if you use cap as, it does extend it. Okay. Can we do it 60? It will crash. Out of range, yes. Okay. A 0 value of a slice is null, basically any pointer. Creating a slice with make. This is how you create a dynamically sized array. Okay, it's like new. But is there a vector? Slices of slices. Slices can contain other slices, cool. Appending to a slice. Append, yes. Okay, so Go doesn't need a vector structure because append automatically does it. The slice grows as needed, which is what if you're pointing to an array? Equal var 50 int. What if you do it like so? Hold on. As type int in assignment. Can we do it? Okay. So you first start with stack array, and then it magically switches it to a heap array. That's nice. Not gonna lie, that's pretty nice. Although, like, you wouldn't know what's happening you genuinely wouldn't know what's going on. But this is not C or Rust, so that's fine. Range. Finally, a range. Okay. Range. That's what I was looking for in the loop. So there are ranges. Right. Oh wait, it has to be specified range. That's what I was wanting, and I like that. Range continued. You can skip it. Yes. The underscore. Yes. Thank you. It's awesome. Wait, can I just have a range of numbers? How? So if I... Wait, what a... If you only want index, you can omit the second variable. How would I... Can I make a... Can I do something like this? Oh wait, let me guess. It will be like slices. It will be like slices. No, it's not. It's not. Which makes me sad. Okay. Can I have a range from 0 to 10 without specifying the break conditions? Golang range of numbers. Okay. So you create an array just for Rust for range numbers. Okay. So well, oh well, there is, basically I was looking if you could just do like this. If you could do like this, but you gotta do this, or you gotta you can go overkill, and yeah, you could go overkill. I swear to God, you could go overkill and do for I range make bool 10 fmt.printf, and this, yes, I got it. We can make a range we can use range, but it will create an array on memory with the size of the range. And it will use memory, it will use allocations, and it will in the end be longer than for a 0. In the end, it's actually longer than the regular for loop. Oh, in the end, it's longer than the for loop. Yeah, so they basically say don't do that. Well, they could very easily make it like this, but they won't. Oh well. Okay, fair enough. Fair enough. Exercise slices. Implement pick should return slice of length dy, each element of which is a slice of dx, 8-bit unsigned integers. Hold on. All right. Oh, should we use %v, not %d? Is v like automatic value? That I guess makes sense. I guess they kept %d for like being a explicit and b similar to c, which is like explicit types. Well, yeah, you need a loop to allocate each int 8 inside. Should return a slice of length dy, each element of which is a slice of dx. Slice of dx, 8-bit unsigned integers. So for 0 dy, oh, we can actually do it. Make uint 8 dy. Yes, for y and value range sub make oh god, I can't type. And we create that, and for equals range v, yes, let's make it, oh wait, this is line, let's just make it line v equals, I wonder, can we assign that? Hopefully. Uint 8. Interesting functions. X plus y divided by 2. Let's just do that because it seems like something that would actually fit in there. 256 values that exist. X plus y divided by 2, because x to the power of y, that surely won't fit. Can we do it? Return ret. Oof. Finding module for package. Undefined v. Wait. Oh. Yeah. V declared but not used. Where the hell is that? Gotta say that our message is V declared but not used. How so? What do you mean by that? What do you mean by that? Does this work? Why declared but not used? Wait, I surely am missing something. Can I right click, open a new tab? I surely am missing something out. For range. It should be it. Range POV. Why? Oh, why? Oh, why? Oh, why? Okay, so is it? What? Hold on. Okay, so we can have the 10 and we have make. Is it like this thing once again with this? Undefined ret, no. Help me. Help world. Can we do this? All right. And what? Okay, wait. Does Go not have multi-line comments? Why declared but not used? What? What? Okay, so I cannot assign it. What if I use Y? Yeah, all right. Can I do this? Can I do this? I have no idea. Okay, so I cannot do this. And then I can just use return Y like this. Yes, we compile it and yeah. Okay, so I cannot this makes things horrible. What am I doing? Do you think I know what I'm doing? Undefined line. Yeah, I did something. Look at that. I got the image. What are you talking about? I got the image. Yes, it prints. Yes, for loops. I don't know. How can I iterate over references? Can I value line range over pointer to this? Nah. This cannot be the case. No. Cannot iterate over that. Can I do this? No, alright. Let's just keep it as it is. So like the thing is, I would ideally want to have it as line right here, the value, which I could assign right here directly and not have to index it manually. But it appears like that's not how you do it. What if? No. This can't work. But yeah. Here we go. Let's try x times y. Ooh, fancy. Can we, does this XOR it? Yeah, it XORs. Ooh, that's nice. Exclusive ORing. Yeah, fabulous. So for loops, not as versatile as in Rust. Maps. Let's do maps. It's 2 hours. What is a map? Map keys to values, yes. Nil. Nil map has no keys. Make function returns a map. So we create a map. Wait, so it maps strings to vertices. You need to use to assign variables. Isn't that that's to declare variables, right? Does it stay here? Oh wait, it keeps it. It, like, as far as I understand, declares them by using the shorthand. But if you like assign them afterwards, you use the equals, I think. Wait, I'm sure can't do this. I swear to God, I can't do this. No. Why declare? It declares it, but not like it puts it on top, I suppose. It gotta put it on top. No new variables on the left side of that. I think that's the case. I'm not sure. I'm already like getting a little overloaded, gotta say. Bell Labs, yes, Bell Labs. So map, cool. Syntax, weird. Map syntax, weird as hell. Map syntax, weird. Oops. There we go. It's weird. So map. So instead of, so you define the key here and vertex here. Yes, that should be it. Wait, what does M mean? Oh, what does that? Okay, yeah, that's it. Maps, map literals. You can define it like this. This is Python-like, very Python-y, very Python-y. Map literals Or is it more like C++? I don't remember. So basically, you just like can declare it as a struct which maps this to that. And yeah, it works like that. Map literals continued. A top level type is just a type name. You can omit it from the elements of the literal. Wait, did it? Oh, yeah, that makes sense. Mutating maps. You can just assign it and it will create it. It will get it. It will delete it. If key is in M, OK is true. If not, OK is false. If key is not in the map, then lm is the zero value of the map's element type. If lm or OK have not yet been declared, you could use short declaration form. Yes, that makes sense. Maps, exercise maps, implement a word count. It should return a map of the counts of each word in the string s. The function runs a test suite against the provided function and prints the success or failure. So wait, it should return a map of the counts of each word. Huh. Wait. Ah, all right. Var w map string int. Will this just work? Will this just work? Return W. Yes. Make map string int. Can we just do it? Yes. Fail. I am learning Go. Fail. Yeah. Booyah. Oh, okay. Oh, oops. For as in as strings.fields. Can I just do like this? Can I do it? No. Syntax error. Oh wait, I just wrote it in Rust syntax. Used as value. Wait. Sub. Oh, it's an index. Here we go. Oh yeah. Can we do it? String. Yeah, we gotta use strings.fields s. Undefined import strings. Yes. Failure. Go. Oh wait, we passed. We passed the initial test. Oh. Yes. Yes. Here we go. Pass. Yes, I'm now a professional Go coder. We can just do this. And do this. And this will be Go. Yes. I think so. Range. Here we go. We do have range. That does work. I think we could actually we could make it less readable and use S. I think. Yes, it does work like that. Ugh. A few things left. Function values. Functions are values too. They can be passed around just like other values. Function values may be used as a function argument and return values. Okay. I mean, you just pass it like this. To be honest, is that any clearer than the C syntax? I doubt. But okay. Okay. Fair enough. But it works, which is fine. Function closure. Okay, closures. That's something I am interested in. A closure is a function value that references variables outside its body. The function may access and assign the referenced variables in the sense the function is bound to the variables. For example, adder returns a closure. Each closure is bound to its own sum value. Okay, so it's like Rust. It creates sum, it binds it to the closure, and it returns everything. Like in Rust, it returns a structure which has internal state, which includes something. In Go, I guess it's pretty much the same underlying, but it's just like not a detail you care about. And yeah, it just returns this. So closures are basically just regular function definitions, but they reference these things, which is cool. But what if? What if? Okay, so we do have that. What if? Sum. This surely has to access the global state. Non-declaration says, okay, it cannot access the global state. I thought I was gonna be able to abuse it very well, but I can't, which is good. Fibonacci sequence. Fibonacci is the sum of the previous two. A, B, is it like that? Return func int, and that is that C? A plus B. B equals C, return C. Is that so? Oh wait, it needs to return. Wait, I forgot. So wait, it does it, kind of. I forgot how to do Fibonacci numbers. Oh wait, it first needs to return A, then B, and only then C. It ret A and just return here we go. We got it. We got him. Which means which means we can clear it up. Alright, well, whatever. It's something that works. You finished. Oh, we still got methods. Oh god, there's a lot. There's a lot. Ooh. Ooh. It's getting a bit too much. I need a break. We'll be back. We'll be back in a sec. I don't know, Delusion, if you left or not, because it says one viewer. It could be just me, but thank you for being around. See you around. Alright, I'm off for like 5 minutes. Hello again, stream. And yeah, we're back. So, we've got one section left, but we're just gonna go really fast, really quickly over it. And like, oh wait, why does it? Methods are functions, so like, yeah. So here's the thing. The receiver argument. Yes. So, okay, my goal is right now to just very quickly go through this and then just jump in and make some kind of backend type thing. And yeah, so like basically, let's just get right through this really quickly. All right, so the first thing I noticed is this. Yeah, it confused me from the very start. I was very confused what it meant. But this is basically like, this is basically the this parameter that on like C, C++ is implicit. You can just do like on C++, this x equals 234, whatever. That's how it works in C++. But here, you can have this v vertex as a receiver, and am I going to make a backend API? I'm gonna try something like that. I am. Welcome back, by the way, and yeah, that's something I'm gonna try to do. I don't know how it will turn out. It will be horrible, but at least it will be something. And I don't know if I will succeed or not, but let's go. Let's try. So yeah, basically one last thing before it's 4 p.m. here. Functions can be defined on types and have a receiver arg func v type func name red type. Yes, here we go. That's it. Methods are functions. Yes. Methods continued. You can declare method on non-struct types too. Yes. Pointer receivers. Okay, this basically makes it a reference type thing. So I want to hold on. This particular thing we had so long ago. Let's go back to it. Can we do a line? Can we do it? No, okay, we can't. I'm never coming back to it. Here we go. So, oh wait, pointers and functions. Yes, that's simple. Method and pointer indirection. Compiler, okay. Yes, fair enough. While methods with value receivers take their value pointer as a receiver when they are called. Okay, yeah, fair, cool. Choosing value or pointer receiver. The first that modify. The second is to avoid copying. And in this example, even though apps method doesn't need, in general, should have either value or pointer receiver, not mixture of both. Yes, fair enough. Interfaces. Interfaces is, I guess, like traits. I don't know. I don't have much time for it. Type appster interface, and appster is for anything that has abs. Cannot use v. A equals v. Because why? Because this doesn't have it. Here we go. Easy. Interfaces are implemented implicitly. So interface is just like function requirements, basically function requirements, and you don't need to say that I'm implementing this interface. Meanwhile, in Rust, you specify I'm implementing this particular trait, which is basically interface, and without specifying it, it won't work. But this, it's like we have method m. If anything has method m with specific arguments, it works, just works. Interface values. What? So we have value and type. Describe. Okay. Interface values with null values. Okay. Oh my god, there are null pointers in Go. Oof. That's a yikes. That's a yikes. Oh no. Oh no. Null interface values. Okay, so the interface itself can be null. Like the variable with the interface can be null as well. Empty interface. If you accept anything, you accept empty interface. It's basically like generic type, except like, all right. So wait, can we? So it accepts anything. This is an odd language choice. Why not just make a keyword that does it? But okay. If I does not hold t, Okay, so this is basically typecasting. Dynamic casting, yes. Type switches. Okay, that's cool for settings and stuff. Stringers. What is that? Stringer is a type that describes itself as a string. Okay, it's just basically a toString method. Cool. Exercise stringers. So wait, I just implement a string like this. As IP address fmt oops. IP 0, IP 1, IP 3. Oops, IP 3. Here we go. Here we go. Did it. Done it. Errors. Ooh. Error is a string. It returns an error. Okay, cool. Exercise errors. It okay, well, it's not worth it. Readers. Reader. Read int and error. Read byte. Read to something. Okay. Just read. Just read. Okay. Exercise readers. Implement reader that emits an infinite stream of ASCII character A. Oops. So it reader returns what? Okay. So wait. Func read byte. Oh wait, it like already accepts this. Can I just do this? And error. For a range equals A. Will this work? Return len O. Nil. Will this work? This won't compile. Okay, it did, and it did work. That's surprising. Good job, me. Pat on the back. Here we go. Next thing. Rot 13. What? Modifying the stream in some way. gzip reader takes an IO reader and returns a reader that implements a reader. Modifying the stream by applying rot13 substitution cipher to all alphabetical characters. Let me just copy this. All right. Rot 13 reader read thing. Read O for range O. Let's do this and okay. If okay. If char right. I'm just not exactly how many characters are there? 25. Rot 13 does it just like rotate 13? Rotate by 13 places? Yes, that's simple. Basically. Char equals a plus int what oh 25. Will this compile? Probably not. Expecting comma or something else. In the can we just do it like this? Oh wait. Right. B declared but not used. Where is B? On B. So yeah, we just do the same thing. Char and char. Oops, no. No. Also, I think that's 26 characters because it's including Z or Z, depending on which country you reside in. Maybe this works, maybe doesn't. Probably it's incorrect, but who cares? Right, images. Image interface. Yes, there is an image interface. Great, that's enough. Goroutines. Goroutine thread thing go say. It just basically runs it on another thread. Yes. So Goroutines channels are typed conduit. What is I don't know. I need to translate this. Oh, channel is a channel. Okay. Through which you can send and receive values. Send V to channel, receive from channel. That's weird syntax. Send V to channel, receive from channel. That's like C++. Make channel. Okay, this is useful in synchronization. This is cool. This is cool. Buffer channels. Yes, we can set a buffer, range, and close. Oh, wait. We can use channels. We can use channels for like generating a range. That's how we can get. That's how we can get a proper, you know, for range. Let's do it. Func range and int c chan int close c for 0. Yes, we are getting done. We are gonna get a for loop for a I in range. Go. I range. Arrange 10C. Wait, I could, yeah. C make chan int. Yes, this is so much longer, but we did it. We made Go a better language. It didn't work. Okay. 30, line 30. Can we just scope this up? Yes, hopefully. Syntax error expressing 32. Oh, go. Yes, we made a better for loop. Yes, can we created a channel. Can we make it one thing? Doesn't matter after all. Select. You cannot, this is like pattern matching. What is X? Multiple operations. What the hell? Oh, when it receives a thing in the channel. Okay, so you've got 2 channels. Cool. Yes, channels are cool. Default selection. Default. Yes. Boom. Okay. Equivalent binary trees. I'm not gonna do the binary tree walk. Mutex. Yes. Mutex. Web crawler. Okay. Where to go from there? They made a pun. Here we go. All right. Yeah. Okay. It's kind of a lot of stuff. Let's make a Go thing. So, all right. So this was Go. A lot of stuff. Yes. One page. Let's now try to create a project. What should I create? What should I create? What's in github.com? Who's using? Is this like the what is Goldmark? I don't know. They put some code in my computer. All right. How to create a Go programmers organized in packages, collection, source files. Yes, everything repository contains one or more modules. Yes. Module is a collection of packages released together. That you don't need to publish your code to a remote repository before you can build it. Well, that's good. All right. Where the Go command should look to download it. All right. Can we? Okay. Let's do it the wrong way. Epic backend. cd epic backend. Okay. All right. Haha. Yes. Okay. Let's just recreate this. Here we go. Epic backend. Then Go mod. Yes. Go 1.14. tmux. Just go to mod init in the current directory. I think I did init it. That means I have this next create a file name. So yeah, like I think I did it. I think next create a file name hello.go. Oh wait, package names do not have to be equal to the file names. That is like C. That is horrible. Okay. 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 Is it in SRC? Maybe? All right. Hello to go. Package main. Func main. Wait, is it? Yes. Just you go run file name to go instead of go install. Alright, that's cool. Thank you. I need to import. Let's remember, import. I just use. Wait, what do I need to import? FMT. Yep, we'll do that. But I first need to create file name.go, don't I? fmt.print. Yes, we backending. Go run. Yes, we backending. All right, so now the thing is, I have no clue how to do it. Let's have some water. And once we do have it, all right, this is a lot of stuff. Importing packages from your module. So we have more strings package and use it in hello program. Yes. And then file name reverse. All right, a lot of stuff once again. It's exported. You won't spoil the fun for me. This is the fun. Yes. I hate you. No, that's fine. Let me figure it out. Also, does Go use spaces? Or tabs? The question is, does Go uses tabs? But my Vim config uses spaces. Well, rest in peace me. I guess Go has formatting tools, right? And once we're in, yeah, it's tabs, but I'm all working in spaces. Even though that's less efficient, but my Vim config is tailored for Rust. So yeah, okay. Okay, importing packages from remote things. Oh, we just do that. Okay. So this is where we get to the point where I have no idea what I'm doing. I'm doing it in a new programming language, and if you have noticed, we haven't seen a single Stack Overflow page open during the stream, which is wrong. We need to open some Stack Overflow pages to look for a tutorial how to make a backend, because I have no idea what I'm doing. And this is how real programming is done. You have no idea what you're doing and you just do it, and you just copy and paste the code in, and you just get it done. You don't know how it works until you rewrite it 50 times, and then you know how it works, and then you become an expert, and that's how you get a 6-figure salary. How am I getting IntelliSense in them? It's not IntelliSense. It's some auto-completion thing. So this is SpaceVim. It's horrible because it crashes every so often. But it's like a completion plugin. Wait, SpaceVim dot init. Is it? No, it's not that. I don't know. Which was it? Vim dot space vim init TOML, and this is my config, which sets the dark theme, and there's an autocomplete layer, and I'm actually not exactly sure why it works, how it works. I used to use uCompleteMe, which works and is lightweight, and it doesn't crash things, but SpaceVim looks beautiful, so I use it, and it does crash every so often. But yeah, SpaceVim has it. It's probably not IntelliSense, but some completion plugin. I need to configure Vim. I want to create a Vim config that looks like this, but doesn't actually pull any of the bloat in, and still has the auto-completion. The best part. But that's for another time. Now, where was I? That's right, Googling how to get a 6 or 7 figure salary. That will be... why is Amazon pinned? And Google... Why is Google pinned? Doom Emacs. I haven't tried Doom Emacs, although there was a period where I used Spacemacs. What is Doom Emacs? I probably shouldn't be searching that on... Isn't... Okay, that looks cool. Wait, isn't this Spacemacs? Because Spacemacs is like this. Although actually it's different-ish. But yeah, I used Spacemacs, but it was also bloated. And configuring it was a total mess because it uses Lisp and stuff. But yeah, so no, I haven't, and I will hopefully not get back to Emacs. Although it's cool if you configure it well, but I won't. I don't have that time. Golang, write a backend. Yes. What is the sorcery? There isn't a single Stack Overflow post. Write a simple... Wait, what kind of backend? HTTP backend. Okay, a Medium article. That may be okay, because, I don't know. Medium is just something that looks okay. Maybe they have quality content. It looks quality. It has helped me out quite a lot. But maybe it's not. Who knows? Go install. Okay. So there is a Golang tools. Oh, Vim binding. So that's like Spacemacs. Yeah. I wouldn't be using Emacs with Emacs bindings. I already spent enough time learning them. I'm stuck with them because, well, at least it's like 50 kilobytes of size and runs on anything, unless you install SpaceVim, which makes things slow. Genuinely, when writing Rust, sometimes SpaceVim lags behind their characters appearing on top of each other, and there's like delay of it clearing of like 10 seconds, and it's horrible. I should just remove it, but it looks so good. It looks so good. That's what we will say about IntelliSense. No, IntelliSense doesn't work most of the time. All right. So there is, yes. What do we have? You know, is there a Go package thing? Inserting dummy data. Ooh. All right. Here we go. This is the code. So we have the port. We have make sure that the port is set, and we create a router, whatever that is. Which router? Where is store? Where do we define store? Oh wait, rest and go. Yeah, these tutorials use some libraries mostly. Yeah, I mean, that's how things are done in Rust as well, which is the quickest way to get it done. To be fair, that's fine, as long as it doesn't become as horrible as Node.js, where is even package depends on is odd package for checking if number is even. Thank God. Unless, I don't know, I haven't tried Go long enough to know. Also, so one of my impression of Go is that it's like directly pulls code from GitHub. Is there a Go package repository? Golang package repository. Okay, so Golang does have packages. Okay. Okay, wait. So all of these are like, for instance, is net a built-in thing? Do we have other packages? Okay, it's becoming a bit confusing. On Rust, it's super simple. Crates.io, search for a package. Tokyo, here we go. Here's a package. You run it. They made it super simple. Here, what the hell is going on? Net is built in. All right. Cool. Okay, so reference on trace. Okay, Golang doesn't have a centralized package repo. Okay. All right, that does make sense. Yeah, so wait, what about rest and go? Is that's also built in? Is that also built in? Or is it something you define in the configuration? Oh, that's our okay. That's the name of the packet, the whole thing. All right. Okay, that's fair enough. Yeah. All right. Got it. Yeah. So all the packages from third parties are on like cloning directly from GitHub, but like there are built-ins that are specifically made for networking, I suppose. Mostly. I don't know. So whatever the handlers are. Some routers which we shouldn't use because okay. That's a lot of Go code. That I'm not gonna lie. Yeah, it appears so. That's all. So like I'm already 3 hours in, and I'm already feeling tired. That's a lot of code for getting a backend running which does some authentication and stuff. And you know, in Rust it would be so much shorter. In Python it would be so much shorter because probably they have like a package managers, package repositories, which would have all this code like written up. Huh, that's interesting. So you kind of need more boilerplate code. That's my language impression. Okay, see the example of NetHTTP. Good. Rust. Oh wait, I went Rust. Golang NetHTTP sample. Does this Go web examples? Okay, that is short AF. Thank you. Here we go. My yes. Yes, this is how we do it. Can we? Alright, I should probably set up AT80 port. So I can actually use this. Okay, whoops. I suppose that's not the official website. But at least it didn't have any third-party packages. So yeah, I mean, Go web examples, that's definitely not Google. Also, legal disclosures. Yeah, that doesn't look like Google. You wouldn't use at Gmail if you were working at Google. Also German, but I mean, as cool it runs. And oops, it says So we can actually fmt.printf. Yes, we backending, which we can then run. Refresh this. Yes, we backending. All right, so what do we have here? All right. Welcome to my website. So HTTP handle function. Okay, so it just kind of does it like magically. It has like a singleton type of thing. Like you don't create an object or something. You just create HTTP handle function. Oh yeah, probably log.println would be better. But yeah, like the basic idea is that, so like it seems like they love to use just like generic like global calls that have internal state or something, instead of making it all compacted and all like localized. In Rust you can't have globals. Here it seems like you do whatever you want. Seriously, it seems like that. But yeah, using log, I suppose implement log, and that will be log println. But I will need to probably do this thing, log.println initialize. This is like all caps. This is such a horrible practice. Don't follow any of the stream as like genuine programming practices. Learning practices, maybe. Programming practices, no. Okay. We have that clear. Thank you. Okay. Initialize back. Okay, so it has the timestamp, and I like that. Also, F5. Yes. Yes, we're backending. Okay. What can we do? Oh, that was simple. I swear to God, that was simple. It just feels like I was gonna struggle a lot more. Now we can go install. Go run. Oh wait. Epic backend. Wait, is go bin epic backend. Yes. Hoo-ya. We did it. We got an actual. Wait, did you? Alright. So now this can be published to the package managers. And yeah, we can add a very restrictive license to this because it's proprietary code. And we can make a quick buck on the street. That's how you get a 7-figure salary, ladies and gentlemen. Yeah, maybe there are some more steps in between and afterwards especially. So what can we do? So let's first find the official example. Examples. That was a loud oof. Documents. Oh wait, that's the same page. Package documentation, yes. Net HTTP, yes. So we can get things. That's cool. Okay, but I need, this is a server. This is client, I need server. All right. Well, I mean, I want to have like a request where I could just submit something through JSON to the thing and it would print it out in the backend. http.request. Let's just check http.request. http request 480 matches. That will be fun to find. Match case. We go back to 216. Yeah, oh, here we go. So we have handle func and we have handle. So let's see. Handle. Here we go. We found the examples. Cool. Handle registers the handler for the given pattern in the default servmux. The documentation for servmux explains how patterns are matched. So we handle the count by doing new. What is new count handler? It creates a count handler and that does it. Oh yeah. So we handle the root and it does work. So yeah. Now we just want to get the data of like the form data. Oops. Something like this. I don't know. But that's a lot of tabs. That's a lot of tabs. Wait, which is the first tab? Yes. Go. Go away. Listen and serve. Listens to TCP network address and then calls serve web handler on request of incoming connections. Listen and serve. That's cool because you just like listen and serve and that's your TCP backend. So yeah, something like that. So I still need HTTP request as a structure. Where the hell is request? Type request. Here we go. Requests represent a HTTP request received by a server to be sent by a client. The field semantics differ slightly. Method, URL. So if we have get, post, put, etc. So I mean we don't actually like have anything in a static directory. We can just remove that. We just need to handle the form data. Form There we go. Form data. Let's just see. Error.form. Let's see. We don't have any form data. Wait, how does... I forgot how... Let's watch a YouTube video to see how the form data is separated. Oh, I can watch on my stream. Here we go. We can do hi equals dad. And we have... What? You were supposed to get parsed. Oh wait, this is horrifying. Huh. For a key value in range r.form log.println key value. Oops. Let's try again. It doesn't parse the form. Wait. Right. No, you. Okay, wait. Let's try something different. Index.html. So that's not something that works. Right, so something different. What if we just print our... Here we go. What do we have? We have think. Ooh, we have the URL. Do we have... Golang parse HTTP GET request. Yes. URL.query. Here we go. We are becoming URL.query. We are becoming professional Golangers. Yes. Yes. Welcome to my website. r.url.query hi. Oops. No, that's not how it's supposed to look. Here we go. Welcome to my website. Square bracket, dad, square bracket. All right. How do I just do that? Dot string. This won't compile. Here we go. Yes, we did it, except we can break this. Yes, this is the peak of website engineering. We crashed it. Okay. But hey, welcome to my website, square bracket, square bracket. Yeah. So yeah. Pooh, did it. Pasted some code in Golang. So yeah. This was, I don't know, a good introduction to something I am not familiar with. But yeah, I guess it's the perfect time to go because I haven't eaten in a long time. Now that I've definitely earned enough money for food, I can eat. But yeah, thank you guys for watching. Thank you, Delusion. Huge shout out to you. You are the only one active in chat. You're probably the only one watching the stream right now. But yeah. So thank you all for being here. And next stream might be something more advanced. I don't know. Maybe the kernel series, maybe some other programming of other projects I'm doing. I don't know. Honestly, we'll see. So yeah, thank you everyone, and see you around next time, and cheers. Bye.